Hello and welcome. Today we're going to continue our discussion on graphing quadratic equations by discussing the direction in which a parabola faces, as well as the domain and the range of the graph. First, let's remember how to graph a parabola. Our first step is to identify the vertex of the graph. Our vertex follows the formula where the x value equals negative b over 2 times a. Now remember, in your standard form of a quadratic, the coefficient in front of x squared is a, in front of x is b, and the constant term with no variable is c. So here I have a negative of a negative 6. Since my b value is negative 6, over 2 times a positive 3. Negative of negative 6 becomes positive 6 over 6, which is 1. This is the x value of my vertex. Now, since your vertex is a point, I also need the y value, so I go back and I plug this in. F of 1, or the y value when x is 1, is 3 times 1 squared minus 6 times 1 plus 2. 3 times 1 squared is just 3 minus 6 times 1, which is 6, plus 2. 3 minus 6 is negative 3, plus 1 is negative 1. So your vertex is the point where x is 1 and y is negative 1. This point goes in the middle of your chart. We now need to find 4 other points. I'm going to find 2 x values that are smaller, so 0 and negative 1, and 2 that are larger, 2 and 3. I'll go ahead and plug these in to complete my chart. F of negative 1 means I'm plugging in a negative 1 everywhere I see an x. 3 times negative 1 squared minus 6 times negative 1 plus 2. Negative 1 squared is a positive 1. Negative 6 times negative 1 is a positive 6 plus 2. 3 times 1 is 3 plus 6 plus 2 gives us a positive 11. Go ahead and take the time to complete the chart on your own after pausing the video for a moment. You should have 0 and 2, 2 and 2, and 3 and 11. Now we'll go ahead and graph. I know this won't fit perfectly on your graph, but we'll go ahead and do our best. I have the point where x is 0 and y is 2. I have the point where x is negative 1 and y is 11. That's a little off your graph. I have the point where x is 1, y is negative 1. I have the point where x is 2, y is 2. And x is 3, y is 11. Again, that's a little beyond your graph. We connect these in a smooth curve to construct your parabola. Go ahead and pause the video again and try the next one completely on your own. You should have a vertex of negative 1, 5. After that, your chart should be completed with negative 3, negative 7. I'll go ahead and plot that point. Negative 3, down 7, 1, 2, 3, 4, 5, 6, 7. The second point, negative 2, positive 2. Third point, negative 1, positive 5. Third point, 0, 2. And last, 1, negative 7. Connecting the dots in a smooth curve, we have our parabola. Now the difference between the two graphs, you might notice that one is on the right side and one is on the left side. Maybe one is in pink, one is in blue. However, the primary difference between these two graphs is that the graph on the left is facing upwards, while the graph on the right is facing downwards. The reason for this is in the equation itself. So the difference between the two equations, we have f of x is 3x squared minus 6x plus 2, and f of x is negative 3x squared minus 6x plus 2. The only difference between these two equations is that the equation on the right, the one in blue, has a negative leading coefficient. This leading coefficient, or the negative that's in front of that 3, is what causes the direction of the parabola, whether it will face upwards or downwards, as we see. So on this next slide, I just want to look at each of the equations and see will the graph be facing upwards or downwards. In this first one, all I'm looking at is that leading coefficient. It is negative. So I conclude that this graph will face downwards. On the right, again, I see a negative leading coefficient, so I conclude that this graph will be facing down. Below to the left, this 2 is positive. The coefficient on x squared is positive, telling me that the graph will be facing upwards. Go ahead and pause the video and complete the next few on your own. You should have down, up, down, and up. Again, we are only looking at the leading coefficient and whether it's positive or negative to determine in which direction our parabola will face. We're going to go ahead and put a few things together, and I'm going to add on a discussion about domain and range. The first thing I'd like to talk about is which direction does our parabola face? So looking at this equation, my leading coefficient is positive, telling me that the direction will be up. Now we'll go ahead and find the vertex. To find our vertex, we use the equation where x equals negative b over 2a. That's to find the x value. After that, we'll need to find the y value. So x equals negative b, or in this case, negative 4 over 2 times a, and our a value is a positive 2. This becomes negative 4 over positive 4, which reduces to a negative 1. To find the y value, I then go and plug this in. F of negative 1 is 2 times negative 1 all squared, plus 4 times negative 1 minus 2. Negative 1 squared is a positive 1. 4 times negative 1 is negative 4 minus 2, which is 2 minus 4 minus 2, and that simplifies simply to negative 4. So your vertex has an x value of negative 1 and a y value of negative 4. From here, I'm going to go ahead and graph, and we'll determine what is the maximum or minimum of our value, and we'll continue down through these steps. For now, I'm going to go ahead and create my chart. In the middle, I have my vertex, negative 1, negative 4. 2 points smaller than my vertex would be negative 2 and negative 3 for x, and larger would be 0 and 1 for x. I'll go ahead and plug these in to complete the chart. The first is f of negative 3. You should have 2 times negative 3 all squared, plus 4 times negative 3 minus 2. Negative 3 squared is a positive 9, minus 12 minus 2 is 18, minus 12 minus 2, which is going to be a positive 4. Plugging in your negative 2, you should have 2 times negative 2 squared, plus 4 times negative 2, minus 2. You can go ahead and complete the math on this, but you should end up with f of negative 2 equaling negative 2. From here, your 0 and 1 should give you y values of negative 2 and positive 4. Now we'll go ahead and graph. I've got the point negative 3, positive 4, negative 2, negative 2, negative 1, negative 4, 0, negative 2, and 1, positive 4. Again, we connect in a smooth curve, creating our parabola. This is an upward-facing parabola, as we had said in Part A. The minimum is the smallest possible y value, or your floor of your graph. If you start at the top and go all the way down, the farthest down we can go on our graph is this floor, which is at negative 4. So you do not have a maximum, but you do have a minimum, and it is negative 4. Now our axis of symmetry. Remember, that is the vertical line going through the vertex. Any vertical line has the form x equals a number. So your equation here for this axis of symmetry is x equals a constant, and the constant is negative 1. No matter what y is, x is always -1 along that vertical line. Now domain and range. We have discussed these in the past, but just as a refresher, domain is talking about all of the possible x values for your graph. Similarly, range addresses all of the possible y values of your graph. So when I look at this graph, starting from the left and going to the right, there is no limit to any x value. When you look at your equation, you can put any x values you would like in, and you will never end up with a problem. So here there is no limit to the possible x values for your equation. So your domain consists of all real numbers, or a bold-faced R, such as this. Your range, starting from the bottom, we see that we can't go any lower than -4. But after -4, when we start to go up, there is no limit to how high the graph can go. It will increase infinitely. So your range is only limited in how small it can get. Your y values must be greater than or equal to -4. Since we cannot go lower than -4, your y values must be greater than or equal to that value. I'll go ahead and walk you through one more, and then I'll ask you to do the last two on your own. Looking at this equation, I see that the direction is going to be a downward-facing parabola, since my leading coefficient is negative. To find the vertex, I set x equal to -b/2a. b is now this -8, so I have negative of -8 all over 2 times -4. That's +8/-8, which is a -1. To find y, I plug in that -1, giving me -4 times -1 squared minus 8 times -1, which simplifies to -4 times +1 plus 8, which is a +4. So your vertex is the point where x is -1 and y is +4. I'll go ahead and create my graph by drawing my chart before I continue on through parts C through E. In the middle I have my vertex, -1 and 4. The two x values smaller are -2 and -3, while the larger ones are 0 and 1. Plugging in a 1, we should have a y value of -12. Plugging in a 0, your y value should be 0. Plugging in -2, we should have a y value of 0. And plugging in a -3, we should have a y value of -12. I'll go ahead and plot these points. I have -3, which is right in between the -2 and -4, and -12. I have -2 and 0, -1 and 4, 0, 0, and 1, -12. Connecting these in a smooth curve, we have our parabola, and it is a downward-facing parabola. Because it is a downward-facing parabola, this graph does have a maximum value, not a minimum value, and that would be the ceiling of +4. Your graph may not go any higher than that, so your graph has a maximum of +4. The axis of symmetry is the vertical line going straight through the vertex. So remember, vertical lines all have the form x equals a number, and here x equals a -1. Your domain is all possible x values. From left to right, there are no limits to the x values. It continues going down to the left and down to the right forever, giving you a domain of all real numbers. Your range, however, is limited. Going up and down on the graph, we see that the graph may go down forever, but going upwards, it stops at +4. So your y values must be smaller than that +4. So your range is y must be less than or equal to +4. And that is part E. Go ahead and try this slide and the following slide on your own, and I will display your answers in just a moment. For the first, you can go ahead and pause the video and check your answers. And for this next slide, go ahead and again pause the video and check your answers. Thanks so much for watching. I hope you enjoy the rest of your day.